Hello and welcome to all. This is Rishabh Pandey and I am a physics faculty at AskIITians. Today we are going to start with the fourth lecture or the last lecture of the electric current and its effect. Before this, I hope every one of you must have seen the previous lectures, the previous three lectures in which we deal with the resistance, the heating effect and the common notions of the electric current, that is current, resistance and all these stuffs. Right? In this session, we are going to cover the magnetic effects of electric current. Magnetic effects of electric current, and these are the applications of these topic. And these two are the applications of this topic. If I talk about this, if I talk about this, up till now we knew that magnetic field is basically associated only with the magnetic field. You know? Say if I have a magnet like this is a bar magnet. You know? This is a bar magnet with the north pole and this is the south pole. So this produces a magnetic field. Magnetic field in the direction of, say, north to south, like this. North to south, like this. Right? This is how the magnetic field are produced in a bar magnet like this, structured like this. But the point is that it was also observed that a current carrying wire also produces a magnetic field. Yes, magnetic field is not only associated only with the magnets but also associated with the current carrying wire, right? What was basically observed, that say this is a situation where we have this, this wire in which current is flowing, current is flowing in this wire. Due to flow of the current in this wire, a magnetic field is produced around it, right? So this was basically a magnetic needle effect. Is magnetic effect of electric current is known as electromagnetic effect. It is observed that when a compass is brought near a current carrying conductor, the needle of the compass gets deflected because of the flow of electricity. Although basically how we can say that yes, current is flowing out it, we can say if I bring a magnetic compass here, if I bring a magnetic compass here, magnetic compass over here, magnetic compass, it will start showing deflection. And magnetic compass shows deflection only in the presence of the magnetic field, which comes to rest in the north-south direction, right? So that means if the magnetic compass is moving over here, that means there is an magnetic field present at this point of time, correct? How to find now? If there's a magnetic field, then it should have two properties. The first one is the magnitude, that what value of magnetic field is there, and the second thing is direction, that what is the direction of that particular magnetic field. If I talk about the direction of the magnetic field, it could be deduced by right hand thumb rule. We'll start with this right hand thumb rule. Say there's a wire like this, there's a wire like this, in which current is flowing, say, like this. Current is flowing like this. What I have to do is I have to take my right hand, right? The thumb should be pointing in the direction of the current, which is like this in the upward direction, and I'll have to curl the fingers like this. As you can see, the fingers are curling like this, and that means for this particular wire in which the current is flowing like this should be the direction of the magnetic field. That means if I draw the magnetic field about it, yes, if I draw the magnetic field about it, it will go like this. As you can see, this will be the direction of the, as you can see in this diagram. Since the current is, now if you see, the current is flowing in which direction? See, as you can see, wait, let me erase that part. Now I want to find the direction of the magnetic field for this, but as you can see that the direction of the magnetic field is already like this. This is how the magnetic field is basically rotating like this, correct? And I want to find the direction of the current. That means if I take my right hand and if I curl it like this, Obviously it cannot be curled like this. I mean, when I have to curl it like this, the thumb will automatically point in the downward direction. So then only the fingers will be curled in this pattern, as we can see over here. That means in this situation the current is flowing in the downward direction, right? That means the current is flowing in the downward direction. That means here, as you can see, this is obviously this is a positive cell, so the current will be flowing from here. Current will be here, current will be here in this direction. This will be the current, and then followed by current. This is how we find the direction of the magnetic. That's fine. If I need to find the magnitude, that what is the value of the magnitude? You know? How big or how small is the magnetic field? I have to use a formula, obviously, and the formula of the magnetic force is IBL. What is IBL? I, basically, as you can expect, I stands for current. B, again, as you can expect, stands for magnetic field. And L is the length of the wire. Length of wire. As you can see over here, so this will be the length of the wire. From here to here. This will be the length of the wire. Right? This will be producing a magnetic field around itself, right? And the magnetic field will be given by the formula F is equal to IBL, right? Where I is the current, B is the magnetic field, and L is the length. This produces a force, right? Now, the magnetic field has a unit called as Tesla. Yes, the Tesla company. Yes, we can remember that by that. So I can say that the value of the magnetic field is Tesla. The force is obviously Newton, right? So there's no confusion about that. So this will be the Newton. The magnetic field is given by the unit Tesla. I hope I'm clear till this part. If I move forward, these are now the applications of the magnetic field. Say, and I have taken an electric bell, a mechanical or electronic bell that functions by the means of electromagnet. When an electric current is applied, whenever the current starts flowing, the switch is closed, and as you can see, the current in this wire has started flowing. See, in this wire, I can see that the current is flowing like this. And see, the current is flowing like this. And due to the flow of the current, as you can expect that due to the flow of current, there will be a produce in the production of the magnetic field, right? There will be a production of the magnetic field in this. Now, what we do basically here is that we have those kinds of switches for the electric bells, no? That which basically goes inside and you leave it, it comes outside. For the normal switches are like you put keep it down and it will remain down, right? You need not keep it pressed. But if you have a look at the electric bell switches, it's like you just press it, remove your finger, it's back to its position, right? So they are basically made for the electric bells itself, because you have to break the current. Point is, let's say if there's a current over here, a magnetic field will be produced, and as the magnetic field will be produced, say, as the magnetic field will be produced over here, magnetic field will be produced. Due to the production of that magnetic field, this magnet will get attracted towards this magnet, which will go and hit this bell, correct? This, as you can see, this is hitting this, correct? Due to hitting, it produces a sound. Then suddenly we switch off the current. As soon as we switch off the current, it again gets, this magnet again gets back to its original position, right? So basically this up and down motion makes this hammer, and as you can see, this is a hammer like structure. This hammer go up and down and strike this, which basically produces the sound. Am I clear till this part? Am I clear till this part? Now, if I talk about the next thing is the electromagnets. What's electromagnet? Say, basically the concept remains the same as in the case of the electric bell as well. That if I have a rod-like structure like this, a rod structured like this, a rod structure like this. right? And about this rod, I have a large number of turns of wire, a large number of turns of wire. Each wire will be producing a magnetic field. So if I have the large number of turns for the wire, obviously the magnetic field will be quite strong. Now, because of this, as you can see, the current is being flowing in this, and due to flow of the current, as you can see, these are the magnetic field. These are the magnetic field. A magnetic field will be produced over here. And since the magnetic field will be produced over here, this basically could be used for the scrap work. Can you imagine that? I mean, if I want to pick up the iron particles from the scrap, taking the help from the human, it's like a bit costly and time consuming. Isn't it better that if I just attach a kind of electromagnet in front of a JCB and make it move in that scrap region? That electromagnet will automatically pull all the iron pieces out of it, right? And as soon as it will do so, when it will get back to its position where I need to dump all those iron pieces, you just switch off the current. As soon as the current switches off, this magnetic effect will be ended up, and all these iron particles will get collected automatically in the given region, right? This kind of structure is basically called a solenoid. Solenoid. What is solenoid? When a large number of turns, a large number of turns of wire is made about a soft iron piece. Soft iron piece. Are you getting this? Right? So this is basically solenoid, and solenoid acts like an electromagnet. I hope I'm clear. So as you can see over here, electromagnet is a type of magnet in which the magnetic field is produced by an electric current. Whenever there's an electric current, the magnetic field will be produced by it. Electromagnets consist of wires wound into a coil. As you can see, this is like a coil-like structure. A current through the wire creates a magnetic field which is concentrated in the hole, denoting the center of the coil. So the maximum concentration of the field is like this. And if I draw the magnetic field about it, it will be like this, long wire like this, long lines, and then lines coming and going up. And so the maximum concentration of the field will be, and since all these lines will be like this, this will be like this, and this is the point, this is the center of the coil where the maximum concentration of the field will be present, right? As you can see over here in the animation part as well. As soon as the current starts flowing, see, this is now has been connected. As soon as it starts flowing, all of these will be, see, this got connected, all of these got attracted to it. That means it started acting like a electromagnet, and this has been wounded about a kind of iron piece, and iron nail, basically, right? If I move to the questions, the first one is, on what factors does the force experienced by a current carrying conductor placed in uniform magnetic field depend? See, for this we wrote the formula just now, that the force experienced by a current carrying conductor. So whenever there will be a magnetic field, say there's a wire like this, in which the current is flowing, obviously from this right hand thumb rule, it will go like this, right? So this will be the direction of the magnetic field, like this and this, and this is the direction of the magnetic field, and this will produce a force. The magnetic field will produce a force, and as I just wrote the formula of the magnetic field, that produced by a force produced by a magnetic field is IBL. That means it depends upon I, current, it depends upon the magnetic field, and it depends upon the length of that particular wire. Am I clear till this part? Next is, the amount of heat produced in a wire depends upon, again, the same thing. Material, obviously, material will be there. Length, we discussed it. thickness, the area, basically they are talking about the area of cross section over there. Area of cross section. And yes, so all of these will be the correct answer. Am I clear till this part? Right? Please make sure that you have attempted all the kinds of question papers based on this chapter. Stay safe and God bless you.